Welcome to Philosophy and Faith, where our goal is to help you navigate your intellectual and spiritual journey, especially in regards to topics like God, faith and doubt, meaning and purpose, and more. I'm Nathan Beasley.
And I'm Daniel Jepson. And together we discuss the big questions that humans have wrestled with for thousands of years.
We're glad you can join us.
Hello, welcome to another episode of Philosophy and Faith. We are really excited for today's episode. We have some special guests through God's gift of technology, able to sit here with rabbis Ellie and Aaron, and they are hosts of the podcast Physics to God. And we're excited to pick their brains a little bit on arguments for the existence of God, especially the teleological argument. And so Ellie and Aaron, guys, welcome to the show.
Pleasure to be.
Thank you for having us. Yeah.
Cool. I thought it'd be good to just begin with some introductions. Since we're getting to know you, we'd love for you to introduce yourselves to our listeners. Would love to hear a little bit about your faith journeys and your academic journeys. Ellie, if you would share first.
My name is Elie. I'm an Orthodox rabbi and a mathematician. I grew up in a modern Orthodox Jewish home. And in my home and in my family, we really had a strong balance, a strong value of religion, Judaism, and a strong balance, a strong valuation of the modern secular world, whether it be science and physics, science, philosophy, psychology, things like that. So my father is a rabbi and is a lawyer. My grandfather is a rabbi, was a rabbi and a chemist. And that was my upbringing. I was really brought up. I had pursued a dual curriculum throughout my schooling where we studied the Talmud and Bible. And then at the same time, we also studied all the secular studies. And growing up, as I grew, I became committed and I loved, passionate about studying the Torah, studying the religion. But I was passionate about the world of knowledge out there. And as a kid, I was always very good at math. I was like that math whiz in class, that annoying kid who always knows the answers. So that was me. But I ended up pursuing math and I ended up getting a PhD in mathematics. I studied something called braid groups. And now currently, again, I became a professor at a local community college. I do research in the field called graph theory. And again, I love teaching. I love doing math. I love teaching. I love trying to explain complicated topics to students who have a hard time with them. And simultaneously, I teach Torah, Talmud, and the Bible in the local yeshiva. Yeah, and I've been studying with Aaron for many years, 20 some odd years or so, and we learn Talmud together, we talk science and physics and philosophy and all that. And yeah, okay, Aaron.
Okay. Thanks for having us. My name is Aaron Zimmer. I'm also a modern Orthodox rabbi. The idea of modern Orthodox Judaism is really to try to have Judaism be relevant in the modern world and not to have it be some old archaic religion, but it's that it should grow and develop as the world changes. Judaism should be able to handle that and really express itself in a positive way in the modern world. And there's a challenge between religion and the modern world that exists for any religious person in the past few hundred years, really. And I felt that growing up, I felt that tension between religion and between modernity. And I also followed a dual curriculum. I learned Talmud and Bible together with secular studies and secular knowledge. In college, I got a degree in physics, but I was also studying Talmud through this method called the Brisker method of analysis, which is a conceptual analytic method of studying the Talmud. And after college, I was faced with the choice to either really become exclusively devote my profession towards rabbinics or to try to pursue professional physicist role, and I chose to do something different so that would enable me to be able to study Talmud and Bible and physics and science and psychology and philosophy and all different areas I was interested in. So instead, I decided to try to make money using the methods I learned from the Brisker method of analysis of Talmud and the conceptual modeling methods of physics, quantitative methods, and go into commodities. We're trading oil and gas and gasoline and cotton and sugar, all different types of commodity futures. And I was able to do that for 11 years. And now after 11 years, I was able to retire about 6-7 years ago. And now I really have the time to devote towards studying different areas of my intellectual interests and also in trying to put together some of the more interesting things I've come across to spread those ideas and to teach others the different ideas in physics and in Talmud and develop for myself and convey it to others through the time that I'm afforded from my commodities trading.
That's great. Thank you so much for that background. And I love how you guys are bringing together the interests of mathematics and physics and your faith. So I've really enjoyed listening to your podcast lately and just totally recommend that. It's been so wonderful and interesting. You guys do a great job of sharing complexities in a very, very accessible way. So thank you for that.
Yeah, we appreciate. We made the podcast for people who might not have a tremendous science or physics background. For people like you who are interested in philosophy and in thinking and religion and God, and are just looking for a way into the science, into the physics, even though you might not have the full physics background. And that's what we designed the podcast through, where Ellie gives it a lot of analogies and makes it accessible so that any person who just is interested and wants to know can really gain a lot of knowledge in physics and science and be made aware of the arguments we presented.
You guys do a tremendous job at that. I love the analogies, and I love how the analogies are sustained throughout even several episodes and develop. That's very helpful, but it's also a rare gift. So the analogy of the Lego city and the analogy of a moral law being used in the same way, analogous to some of the laws of physics. Analogies are very powerful ways for us to understand complex topics. And so just my hats off to you guys. I learned a lot. I've read different writers about some of the same topics, but I understood it in a much deeper way because of your podcast.
Thank you. Aaron and I we go back and forth in terms of our teaching styles, if you will, and it comes across in the podcast, but Aaron demands a lot more of his listeners, and he likes to explain ideas in the clearest way, but sometimes clarity is inaccessible. It's oftentimes a little bit not spelled out fully. And I think there is great value to the way Aaron does it, and he says it exactly properly in the most accurate way. But sometimes, me being a teacher in community college, I teach some students math that they've tried to learn 5 or 10 times before I never fully got it. So I appreciate the difficulties that sometimes people have, especially with topics like math and physics. And I think the problem with these types of areas is some people, we really think what we talk about largely in our podcast is what's called the fine-tuning argument. And it's an argument based on modern physics. And we think it's a very compelling argument for the existence of God. But at the same time, one might think it's hard. People are probably afraid to even approach it because physics is so scary and math is scary. How are they going to even get into it? And that's really where we think it's not the case. It really appropriately explained, as you're talking with Daniel with analogies, we really try to break down all the physics and to make it familiar in categories which people could relate to, and allow even a person who doesn't have a background and a strong background in science and physics to be able to see the arguments step by step and to be able to see how modern science provides us a solid, compelling argument for the existence of God.
Yeah, you guys do a great job of complementing each other in that. And we thought it would be neat to get into some of that fine-tuning argument. And I was wondering if you guys would be able to give us an overview of that. And then we got some questions and all that would left just unpack it. So would you do us the honors of walking us through that a little bit?
Sure. So I guess we could start with you could consider the goal of science. And there's a good quote, I don't have it here, but a quote from Einstein, the supreme goal of all of science is to take all the multifarious phenomena which we see in the universe and break them down, explain them based on the simplest possible principles. And that's, if you think about it, you look around and you thunder and lightning and rainbows and everything out in our universe, science has tried to explain them all and tried to explain it based upon laws and to show how everything which we see is a result of laws. And not only that, we see all different types of objects, whether it be a phone or whether it be a pen or whether it be an animal or whatever. All these objects are made up of different components. And science breaks down those into the different components of which they're made. So it might be made of the different elements. And then we see those elements are made out of ultimately of fundamental particles. And the idea is that science tries to simplify, to take our complex world and break it down into most simpler and simpler components, which operate through simple laws. And this is the goal of what science does. And science has been very successful, and specifically, ultimately, physics is successful at explaining, largely successful at reducing and simplifying. And ultimately, science has shown that everything, all the substances in our universe could be broken down into what are known as fundamental particles, like an electron, for example, and other fundamental particles. And those fundamental particles are governed by laws, which govern the interaction between these fundamental particles. And those laws could be summarized by the current state of the art is quantum mechanics and gravity, which is expressed in general relativity. And these laws are the rules which govern the interaction of all these fundamental particles. Now, when physicists have studied these laws, they've discovered that any law, or when you talk about the particles as well, the laws have qualitative components and quantitative components. Okay, so what do I mean by that? For example, gravity, as we know, gravity is that all masses attract. But that's a qualitative description. That the effect of gravity is that they attract. But then you could ask the quantity, how strongly do they attract? How strongly do masses attract? And that's a quantity. And it turns out that's measured by a number. And these numbers are called constants of nature. For example, electromagnetism is another force of nature where opposite charges attract. So gravity says masses attract. Electromagnetism says opposite charges attract. While they both attract, and qualitatively you could think of them as attractive forces, the quantity is totally off. I think electromagnetism is like 10 to the 40 times as strong as gravity. And the idea is that when physicists study the laws of nature, they've discovered that to describe our universe and describe everything about our universe, you need to have these qualitative laws, but ultimately there are these numbers, these constants of nature, which are measured. And the numbers, which, for example, one of the numbers is something called the fine structure, which is related to the strength of the electromagnetic force, is a number like 1 over 137.1397777. There's many numbers, like 25 or so numbers, which are these strange, arbitrary-looking numbers. And these are what the current state of the art is, where science is like everything of our universe can be explained by these two simple laws of nature, quantum mechanics and general relativity. And also you have these 25 unwieldy numbers. And that leads physicists to a mystery. So maybe, Aaron, you want to talk a little bit about the mystery?
Sure. Okay, good. So that's the good background. I just want to, before I get into the mystery of the constants, I just want to make one point. What we're doing here is presenting the fine-tuning argument. It's a fairly well-known argument nowadays for the existence of an intelligent cause. And there's different ways to formulate. There's at least two other ways. We do it a third way, and we think we do it in a unique way. And there's a reason why we do it this way. It avoids a lot of problems that sometimes atheistic scientists will ask about the other formulations. I just want to point out that there's something different what's different about it is this exact point I'm about to say, that it's based upon the mystery. Okay? So let's say, what is the mystery of the constants? That's something that Richard Feynman, I think his book QED was in 1985, he said, for example, one of these constants, the constant confined structure constant, Ellie mentioned before. So it's these constants of nature. How do scientists know how strong the electromagnetic force is? The answer is they just measure. They take two electrons, put them next to each other, and measure the force between them. They could quantify how big that is. How do you get in another one of these constants is the mass of an electron. How big is an electron? How heavy is it? How much would it weigh if you put it on the scale? So that's called the mass of an electron. And how do scientists know that? They just measure it and they say, well, that's how big it is. And the mystery of the constants that Feynman spoke about, which he called one of the greatest damn mysteries in physics, was how do you explain these numbers? How do you explain a number like 1 over 137.039? Where does that number come from? Feynman metaphorically said it's as if the number is written by the hand of God. It's just something that we put into the equation. Feynman wasn't using this as an argument from God. And this is not, at this point in the other stages, there's no argument for God at this point. It's just a question of, it's a big mystery in physics. Physicists are trying to explain everything in the universe. And they've reduced everything down to these two beautiful laws, quantum mechanics and general relativity, and 25 numbers. And these numbers are, to all appearances, in 1985, there were these arbitrary random numbers, complex numbers, many strings of decimal places. Who knows how many decimal places it is? The fine structure constant was measured to, I think it's 8 decimal places or something. But it can go further. It can go 100. Who knows? It's the only way you know is by measuring further. The more precise your instruments are, the more you'll know. And an electron, it's this incredibly small value. And where does it come from? Who determines it? And is it fundamental? Is it that the ultimate reality in the universe is quantum mechanics, general relativity in 25 numbers? That's not beautiful. Scientists are looking for something that's the fundamental basis of reality. And they're looking for something that's simple and unified and beautiful. And these 25 numbers, I think in the words of Steven Weinberg, Steven Weinberg, a Nobel Prize winner, he in his Dreams of a Final Theory, he says it's the exact opposite of what scientists are looking for. They're looking for something beautiful and simple and unified. And instead, you get these 25 numbers that read like a list of data. How could that be the ultimate reality, 25 random looking arbitrary numbers? And if they're not fundamental, and if these numbers are derived from something else, what kind of equation are scientists going to come up with that's going to pop out these 25 numbers? How are they going to find a deeper mathematical equation, a qualitative equation, which is going to pop out these 25 constants? It didn't seem plausible that there would be any reasonable path to accomplishing that. And that was the great mystery, is the way scientists explain things is by showing that it derives from deeper and deeper things until you get to the most fundamental reality. And the most fundamental reality was supposed to be this qualitative law called quantum mechanics. And now it has 25 other numbers that are just additional pieces of information you have to add on to it. And how could you come up with a deeper mathematical law that would naturally, deterministically result in these 25 numbers? It didn't seem possible. And it doesn't seem possible these numbers are fundamental basis of reality that just totally offends everything physicists believed was the ultimate reality. And that was the mystery. And the point I want to make here is just to emphasize is nothing about the mystery has anything to do with fine-tuning. I haven't mentioned fine-tuning yet. It's fine-tuning. You don't even know what fine-tuning is. The mystery of the constants is an intrinsic mystery that lies at the heart of physics in the pursuit of physicists of a theory of everything. In their attempt to try to explain the ultimate foundations of reality, they're faced with 25 arbitrary-looking complex numbers. And the question is, how can you explain something like that? That's the mystery.
Allow me to interrupt. The teacher in me feels like I just want to ask Nathan and Daniel, do you have any questions? Are we talking over your head? Are we not explaining anything fully? We don't really want to be lecturing. So if there's any questions, I think we'll become help if you guys have any follow-up questions.
Thanks, Ellie. Having listened to some of your podcasts or watched them, I'm able to follow where you're going on this. And I would encourage other people, if you're not following this, go listen to those podcasts or those YouTube episodes from Physics to God. One of those 25 numbers that you also talked about and was even more understandable to me, and that was the cosmological constant. And correct me if I'm wrong, but from what I understand, this is the number that determines the rate of the expansion of the universe.
Yeah.
And it has to be precisely balanced against the force of gravity. If the force of gravity is too strong, you have the big crunch, everything collapses, and you don't have any room for atoms or molecules to...
But you're jumping. That's the key point. This is the key point is now you're talking about fine-tuning, which is if it's too big, then the universe expands too fast. If it's too small, the universe crushes. But what's so important, I think, in the conceptual presentation of the idea is to appreciate that the mystery of where does the cosmological constant come from? You're right. The cosmological constant determines the expansion rate of the universe. That was set at the Big Bang and how fast it accelerates after that. That's fine. And it is this fantastically small number. It's 3 times 10 to the negative 122nd or something. But where does that number come from? Why is it that the number? Who determined that's the number? And how do you explain that number? That's the mystery. That number let's say the number could have been anything. And it wouldn't have mattered, let's just say. Then you have a mystery of how do you explain it? Why is that the number? Are we just supposed to accept that the basis of reality is a number like 0.0000 119 decimal places, zeros, and then a 3? Like, where does that number come from? That's the mystery. It has really nothing to do with the fact that, which we're going to explain in a second, that if that number's a little too big, there's no galaxies, the number's too small, then everything just crunches in on itself. That's fine-tuning. Many of the other formulations of fine-tuning, they look at fine-tuning as the problem. The key is to realize the mystery that Feynman spoke about in 1985 he didn't know that. He was talking about fine-tuning. He was talking about the intrinsic problem of how do you explain a number? How does physics explain it in a deeper way? Or are we physicists forced to accept the fact that 25 numbers are the ultimate base foundation of all reality and they're not, there's no other deeper explanation. And this is just what we've come to. That's the mystery.
Okay, great. Thank you.
Okay, so go ahead, Ellie. Why don't you try to explain where fine-tuning comes in?
Okay, good. So this actually gets to what Daniel was starting to lead towards, is that Feynman's mystery was how in the world do you explain these completely arbitrary numbers? They seem to have nothing special about these numbers. Already starting in the 70s, 80s, 90s, the topping came in 1998. is that scientists started to realize that these numbers are not as arbitrary as they thought. And not just a 1 over 137, whatever, is not as strange and crazy as it is. But what's special about these numbers is nothing about the laws of physics themselves. The laws of physics, if you change the number from 1 over 137 to 1 over a million or to 53, the laws of physics would be the same. There's nothing different about them. But if those numbers were different, then the laws of physics would not be able to result. As the universe developed, it wouldn't result in the formation of atoms, of molecules, of planets, of stars, of life. And that's what scientists realize. These numbers are fine-tuned. If you can imagine these numbers having dials, which sets the value of these numbers are fine-tuned, such that if the numbers were not what they're at, what the value which they are, but they were different values, then physics would be fine, but you wouldn't be able to result in fields of astronomy and biology, chemistry. Nothing would result. And that was an amazing clue, a discovery, a scientific discovery, that these values are special. They're special, but not special in terms of physics, special in terms of the purpose, in terms of what they ultimately produce. And that was a shocking discovery, which was surprising to physicists, and it was something which they had to deal with. What do you do with that clue? What do you do with that? And that's what, for example, you talked about, Daniel, is the cosmological constant, which is this red number which determines the rate at which the universe is expanding or accelerate. And it turns out that if it was expanding too fast, then everything would have just pulled away from each other. We wouldn't have been able to have any galaxies form. It was expanding too slow, and gravity would have caused everything to crunch, and you would have never formed galaxies. And a lot of these numbers, as science gets more and more knowledge, we realize a lot of these numbers are fine-tuned, that the values of these numbers are what they need to be in order to produce a universe like our own. And that was an amazing discovery.
Right. Now, the key point is to look at fine-tuning as the solution to the mystery. It's the clue. It's the great clue that solves the mystery. Because the mystery is these arbitrary numbers. How do you explain the number? If fine-tuning is scientific knowledge, which we learn about it. We learn about the mass of the electrons. So these electrons are really tiny. They're almost 1/2000th the mass of a proton and a neutron. But they're not exactly 1/2000th. They're 1,836 of a proton and 1,838 of a neutron. And it turns out if let's say the electron's a little bit bigger than its tiny value, then the 2.5 times, then protons and electrons will be able to combine, the charges would cancel, and you'd end up getting neutrons. And all atoms would collapse, and you would be no such thing as atoms. Hydrogen, helium, oxygen, carbon, everything. All you'd have is everything would become neutrons. And there wouldn't be any atoms and molecules and planets and stars and anything else. And that's scientific knowledge. The only reason you know that is because scientists understand chemistry and atomic physics. And fine-tuning is a type of scientific knowledge which explains one of the deepest mysteries in science, is the mystery of the constants. And that's very important to understand why the whole fine-tuning is not a problem. It's a solution. It's scientific knowledge which points the way to the true solution. The true solution is that we can explain the constants. We understand why they have their crazy values. Why is that in fine-structure constant over 1 over 137? In order to have atoms and molecules and planets and stars. If it was 1 over 140, you don't have any of that. If it's 1 over 130, you don't have that either. And in a lot of these constants, you change them a couple percent and nothing works out. You lose all the complexity and structure and order in the universe falls away. And that is a type of an explanation. Now, it's not the standard type of explanation that modern science had been working with. It's called a teleological explanation. You're explaining the values of these constants by their purpose. And the problem with that for scientists was this is something new. This is something different. Teleology was something where teleology means a purpose-based explanation. That's something that Aristotelian science used to have, but modern Newtonian physics, in theory, got rid of that. And now all of a sudden, fine-tuning shows that it's coming back, that there is this connection of the objective of the constants. The purpose of them is to produce stars and planets. And scientists today recognize this. This is something, so far, everything we've said is something that physicists and scientists will say, maybe in 99%, they will more or less all agree to everything we said. The mystery of the constants that Feynman talked about, and fine-tuning itself, the fact that if you change these numbers, you won't get any of the complexity and order in the universe. That nobody's arguing on that. The question is, how do you interpret it? So this is where we diverge. We think that the natural interpretation and the direct indication of when you see purpose that the constants have a purpose of producing atoms and molecules and stars and planets and life, that the cause of the constants is intelligent, because an intelligent cause acts with a purpose. That whoever set the constants are not truly fundamental. To answer the mystery of the constants, they're not truly fundamental. Rather, they were set by an intelligent cause that set them at their values in order to produce a universe, which is an interesting universe, which has stars and planets and life and galaxies and all these other different, amazing, wonderful things. And that shows you that there's an intelligent cause for the universe. It's not just an unintelligent brute fact of reality of 25 numbers or some random thing that just produces numbers for no purpose, but it shows you that the cause of the laws of nature and the constants of nature is an intelligent cause which acts with a purpose, understands what it's doing, and set these constants for a specific value, for a specific purpose and an objective. That obviously is what scientists don't like. We'll talk about in a second about their approach known as the multiverse. But the main point in following this whole formulation, the fine-tuning argument, is appreciating it's not an argument from the gaps. It's not an argument from ignorance. That very often seems to be the case when people try to argue a teleological argument from biology, which seems to be we don't know how to explain certain things, and you're saying that it must be God is doing that. We don't know how to explain where our life originated, it must be God did it. And we're not trying to knock the argument of biology. It's just we want to show you, and then that's very much why we made the podcast Physics to God. And what we're doing is the first 5 episodes of our podcast, the fine-tuning argument, is because there's a superiority. It's tremendously superior, this argument in physics. If you want to have real conviction that there's an intelligent cause to the universe, the argument from physics is much better than any other argument, frankly, that I've seen anywhere. And it's why we've devoted more than a decade towards developing it and ultimately trying to present it in a podcast and hopefully in the future a book. It's because it's very clear it's an argument from knowledge. And it's not an argument from the gaps where you just simply don't understand the detail in some sort of how cows have spots. But you're dealing with the fundamental basis of reality, the constants of nature, the fundamental constants that physicists call constants. And you're showing there's an intrinsic mystery that scientists acknowledge. And fine-tuning, which scientists acknowledge also, is coming in as scientific knowledge which solves the mystery and points directly to an intelligent cause. And then that's very much why it's so important to formulate it, to see why the idea of an intelligent cause of the constants is simply the natural outcome of following the conceptual unfolding of how physics went from the mystery to fine-tuning.
Okay, I appreciate that. And there's a lot here. Let me see if I could put this into a deductive analogy. So I used to teach logic, and when I was on the debate team, we tried to put things in an argument just so we could analyze them better. That's my first shot, just listening to you, Aaron, talk about that the last 5 minutes. So, deductive argument, you've got 2 premises that lead to a conclusion. Try this out, see if I'm on the same page with you. Premise number 1, the best scientific answer to the mystery of the consonants is fine-tuning. Premise 2, fine-tuning implies intelligence. Conclusion, therefore, the best scientific explanation for the constants of physics is intelligence.
Okay, so you're saying that you're starting off with the fine-tuning is the best explanation for the constants, correct? That is the best scientific knowledge we have.
Okay, so that's the premise 1.
Yeah. It's pretty much the only scientific knowledge we have about the constants. Everything else about them is they're arbitrary. We don't know anything about them. So that's the knowledge we have.
Okay.
And then you're saying, and then if we have fine-tuning implies an intelligent cause.
Yes, that's premise 2.
Yeah. Right. And then if we put those together, since we have a mystery, fine-tuning is the clue that points us to an intelligent cause, and therefore we have an intelligent cause. Yes. You guys are philosophers. I say philosopher.
Solid. Could I just elaborate a teeny bit on the second premise, which is saying fine-tuning leads to an intelligent cause. So I think it comes down to intelligence, how you understand intelligence. So the way we think about it is intelligence comes from some Latin word that you don't know how to pronounce, but it's like interlegere something, and it means like select. And the idea is that you select. Intelligence really is like the ability to select one particular path or strategy or anything from a set of many for the purpose of realizing some goal. And you can think about that in any area. Intelligence is a person's ability to select, to choose. There's a lot of different options out there, and you're choosing one which leads you towards a desired goal. And that being the case, with that idea of intelligence, we think fine-tuning is basically saying the values, as far as physics knows, the values could have been anything. A lot of physicists will tell you there's nothing which seemingly determines that the values are any value, 137 or any other value. But the choice of the constants, the values of the constants were selected as the particular values which are necessary to be able to result in our amazing complex universe. And we're saying that's the signature, fine-tuning, design, order. These are signatures of intelligence. The fact that the constants are selected, the perfect values which will result in the goal of bringing about our universe, that's why that second premise is the case. That fine-tuning implies an intelligent cause.
Okay, that's good stuff. Very helpful. And so again, this is not necessarily a direct proof for God as we understand it. But to me, if this argument is successful, then it undermines naturalism and obviously has a very important purpose then.
Yeah, exactly. So I'll take off on that point, actually, is it's not, from the way we're formulating it, you're not going to get divine providence. In order to get divine providence, you really have to say that there's specifically fine-tuning for intelligent life, for human beings. And that we think is if you don't really have specific fine-tuning for human beings in particular. Yes, it's true. If you don't have the cosmological constant set properly, the whole universe collapses. But then you don't have anything. If you don't have the fine structure constant or the mass of an electron fine-tuned very precisely, there's no atoms and molecules and planets and stars and no human beings, no intelligent life. But it doesn't show you philosophically, if you use a proper philosophical methodology, it doesn't show you that the purpose of everything is human beings. It just shows you that the cause of the universe selected these things to produce a universe with structure and hierarchy and order and complexity and all the amazing, wonderful things that exist in the universe, from black holes and chemistry to stars and galaxies, everything. And yes, life is phenomenal and intelligent life is special, but we're just one part of this amazing universe. And the cause of the universe intended it all, as far as we can tell. Is there one particular part that the cause God likes the most? That's, in a sense, beyond the scope of this argument. But we think, and we think when people try to formulate it that say that fine-tuning is for intelligent life, then they expose themselves to having questions from atheistic scientists and saying, well, hold on a second, maybe there's different forms of life that can, in some hydrogen cloud, maybe it's possible to have life. And you end up opening up the fine-tuning argument to a lot of Christians. And then a person hears that and says, you know what, these scientists are right. But what's really happened is that people have not formulated the argument in the proper way. There's an expression in the Talmud that says, it's in Aramaic, it's tefastamer below tefastam yet tefast. That if you try to grab too much, you grab nothing at all. And if you try to grab a small amount, what you're able to grab, then you grab some. And that's what goes wrong here, is that you try to prove divine providence. You try to get everything out of the fine-tuning argument, then it ends up becoming a weaker formulation that can be knocked off by scientists and philosophers poking holes in it because you tried to do too much. But if you are satisfied by saying, we have the best proof that modern science has ever afforded with the idea of God, who created the universe, caused the universe, set the laws of nature and the constants of nature for the purpose of producing an entire wonderful, amazing, ordered and complex universe. That's incredible in the modern world to actually have science indicating in a very clear, compelling, convincing way to a person that God exists is an amazing thing. And to try to overreach and try to use this to prove divine providence, then you end up losing it all. And it's just a big mistake that we think people often make. And that's, it's start off with God as the foundation of religion. And then if you want to prove religion, you want to prove divine providence, there's other arguments you can use. Yes, they're not the fine-tuning argument. Maybe they're not as rigorous, but still you have to be honest with what this argument proves.
Okay.
Yeah, I love that.
I like that a lot.
Yeah.
Go ahead, Nathan.
No, I appreciate that as well, that you're trying to make it as tight as possible. I guess my question is, there's no one of those 25 numbers that are foundational that is necessary that corresponds to human life. Is that right? Is that right? Is that one way of putting it, maybe?
Exactly. That's the thing, that the closest thing you have is like, there's like a certain element of fine-tuning of carbon, which is a little bit complex, and that's like the closest thing, but the fine-tuning there is disputed by how much the fine-tuning is. Weinberg wanted to say it's like a 25% thing, and that's like the best argument you're going to get is from carbon. There's a certain resonance it needs in order for it to, in the formation of carbon from stars. I think Fred Hoyle is the one who discovered it, and he was an atheist, I think, but still. But that's like the closest, and even carbon, it gets you life, carbon-based life, but still doesn't get you intelligent life. And that's like disputed amongst the scientists. What's so amazing about what the fine-tuning argument as we presented it is there's nothing we've said that scientists would argue about in the framework of science. But the fine-tuning, they agree that if you don't have cosmological constant, you don't have a universe, you don't have galaxies. If you don't have the fine structure constant or the mass of an electron or the masses of quarks or the relationship between gravity and electromagnetic force, the strengths, you don't have stars, you don't have atoms and molecules, things like that. They all say this. You could go online and you could go search videos of fine-tuning and of the constants or the multiverse. Scientists will talk about this when we talk about the multiverse, and they agree about everything we say. What they just say is that, granted, there's this mystery. Granted, the fine-tuning seems to make it look like you need these constants in order for the purpose, but they just say it's an illusion. The proper interpretation, according to them, is that we live in a multiverse, which, if for your listeners who don't know what a multiverse is, it's an infinite number of unobservable other universes where the constants of nature are different in every universe. It's speculated that the constants of nature are different in every universe. And obviously, in 99% of them, there's no life, there's no planets, there's no atoms or molecules, and there's no intelligent life. And in ours, just a few universes or whatever, small subset of them, there happens to be fine-tuning by chance alone. And we obviously are in a universe which has fine-tuning because we couldn't exist in any other universe. And that's called the anthropic principle, that it's an observer bias. And of course, we're going to look around and see a universe which has fine-tuned constants because we couldn't exist in any other universe. And that's their explanation. And we're doing an entire series, our series 2 in our podcast, which is going to come out in November. It'll be about 15 episodes to show understanding the multiverse and rejecting the multiverse, seeing why it's not good science. It's rather bad philosophy because it doesn't meet the standards of science of observation and prediction, and it has more intrinsic flaws, which we'll talk about in our season 2. But that's where they argue. Essentially, it's a philosophical argument of what is the proper interpretation of the fact that these constants seem to be set with the specific values for the purpose of bringing about atoms and molecules and stars. Do you say, therefore, there's an intelligent cause who set them, or do you say, no, it's just an illusion of purpose? It looks like there's purpose because we have an observer bias. And that really becomes a philosophical discussion of what is the proper philosophical methodology for interpreting this. And we say to people is, if you want to believe that this fine-tuning argument is really a good argument for the existence of God, and we're not just making something up, go look at the multiverse. Go on YouTube and watch videos of the multiverse. And when you see the top physicists in the world, the most brilliant people in the world, talk about the multiverse, how they really believe there's infinite number of parallel universes, and everything that possibly can happen does happen. And they talk about universes with smirks in them and universes with people being resurrected. And they literally talk about all this stuff. You're going to realize that there must be a really good argument for fine-tuning, because scientists would not be saying the multiverse if there weren't a strong argument for fine-tuning. And that's another reason why we believe the argument from physics is much better than the one from biology, because in biology, people who are proponents of intelligent design, they're arguing with scientists about biology. They're arguing, is the theory of evolution comprehensive? Does it have flaws in it? And again, we don't want to get into that, but you're arguing scientific arguments with scientists. In physics, when you deal with fine-tuning the constants, you're not arguing physics with physicists. We all agree on the physics. We all agree on the science. The question is, what is the better philosophical interpretation of the fact that the constants are fine-tuned in order to allow a complex universe to exist? Is it that there really is the purpose of the constants and there's an intelligent cause that set it? Or is it that we live in an infinite number of parallel universes which nobody can ever see, nobody can ever test for, and it just happens to be this illusion of fine-tuning because of an observer bias? That's why we think it's a much stronger argument.
Yeah, that's great. So I've got 2 questions. First, from a pop culture perspective, is the Marvel Universe portrayal of the multiverse and like the Spider-Man and Avengers movies, is that accurate from a physics perspective?
Okay, so this is really a subtle question because the multiverse is such a ridiculous theory. I think in the Marvel movies, you can travel between universes, okay? So really you can. In a physics perspective, the whole point of these other universes, they're not causally connected. They're separate bubble universes, and it's impossible to travel from one to the other, okay? But what you could do, and I play this game with my son a little bit, there is a universe that's where if you just run as fast as you can right into a brick wall. So there is a universe where, as soon as you hit the brick wall, all your atoms will just disperse and you will disappear in that universe. Okay. Now there's another universe where randomly that brick wall, the atoms in that molecule, they fluctuate and you pop out of the other side of the brick wall. So because everything happens in the multiverse, when you're dealing with an infinite number of universes and quantum mechanics, everything possible that can happen does happen. So there are portals in the sense that you can run it. If you really believe in the multiverse and you run straight into a wall, there is a universe in the multiverse where you'll cease to exist in this universe. And there's another universe where you'll pop out of it. So you can treat that like a portal between universe. And that really does exist. Multiverse scientists really believe in this kind of things. I don't think they're going to run into a brick wall. I don't know if they really believe in it, but you do. That's the thing. If you think about the logical conclusions of multiverse, which is an infinite number of universes where everything possible happens, you end up with the most absurd types of scenarios, and it really starts to parallel science fiction. It becomes something like that.
Yeah, I appreciate that. One of the things I wrestled with before is whether the idea of an actual infinite is even a tenable hypothesis, an actual infinite of anything. Obviously, you can have the idea of an infinite as being without limit and have a conceptual infinity, but once you start talking about an infinite number of books or an infinite number of molecules, then you begin to have some self-contradictions. I don't know. Am I off base?
Yeah, no, that's good. That's one of the things we're going to talk about on our series about the multiverse is that in order for a multiverse to work, they end up having to posit that they're infinitely many universes. Then there's a lot of problems with multiverse, but one of them, probably the smallest of them, is that that they have to posit that they have to take a side on this ancient philosophical debate of whether there's such a thing as a physical infinity. And it's not so simple. There are potential contradictions that you get into. We don't want to take a stand on that, but that's one of the things that multiverse has to suggest is that there are infinitely many universes. Physical infinity is possible. And that's part of their model is that they end up having infinitely many universes where everything possible happens somewhere. So that's definitely one issue. But again, it's arguably one of the smaller problems with it. We've got a lot of problems. But it's something which people don't often say. But there's a physicist named George Ellis who makes this point. He said that somehow physicists, multiverse scientists are ignoring that problem and just treating it like it makes sense and there's nothing to worry about. But there's great philosophers, physicists, mathematicians who have said there's no such thing as physical infinity. But that's not we do point out, throughout our process, in our episodes, we're going to point out a lot of potential problems with the multiverse. And there are a lot of problems, besides for the fact that, like Aaron's mentioning, is that it sounds like science fiction, it's make-believe, it's like all this stuff. But we take this, even though it sounds that way, we take it very seriously and we look into all the potential supports and show the problems, and ultimately culminating in a problem, which we're not going to talk about now, but something called the measure problem, which is the real devastating problem, which ultimately shows that even in its own framework, even if you believe and you accept all the infinitely many universes and the fact that constants change, ultimately it fails. And based on this devastating problem called the measure problem. But more on that in our second series.
Looking forward to that. Yeah.
Yes.
I've often wondered too, okay, the multi-universe is true and there's an infinite number of universes where they have their own laws of physics and reality and rationality, then certainly there are universes where the multiverse isn't true. Anyway, you seem to run into contradictions of different kinds. But I appreciate the point that you made, Aaron, that when you start proposing a multiverse, you're stepping outside of science, you're stepping outside of physics, and you are in the area of philosophy. A lot of people just don't seem to understand that. And there seems to be a presupposition of philosophical naturalism that guides all that they're doing to such a degree that they don't recognize that they've already made a philosophical choice that's guiding what they're doing. So I think from what I understand anyway, you're exactly on point there.
I love science and I love physics. When you read physicists of the earlier 20th century, they knew philosophy. Einstein and Bohr and Schrodinger and Heisenberg, they were knowledgeable about philosophy. And then something happened in the middle of the 20th century, maybe the later part of the 20th century. To some degree, Feynman's responsible for it. He's so influential, where this physicist developed like a disdain for philosophy. I think Stephen Hawking started one of his books with philosophy is dead. and science and physics has become the new way forward, and philosophy is over. And that attitude of just looking down on philosophy in this stage has caused modern physicists and scientists to look askew at philosophy. And it's glorifying their ignorance of philosophy. And that makes them unaware of that they are taking philosophical positions that are controversial, and they don't necessarily work out their theories in a philosophical framework because they think they're just doing science and shut up and calculate. And as long as it works out, you're doing science. And then they don't understand the foundations of physics. They end up doing multiverse and thinking it's science because it's mathematical, when they really veer beyond what classical science is, and it becomes philosophy. And it gets worse, and because they hate philosophy so much, because they're scientists and philosophy is bad, and I don't know why they really don't like philosophy. Then they have to call what the philosophy that they are doing, they have to call it science. And they really have discussions about changing the definition of science in order to accommodate multiverse. And there's articles written about it. Sean Carroll has an argument by doing it. Brian Greene talks about it, and Ellis obviously doesn't like it. But there's this big question amongst physicists of, can we legitimately change what has been the classic definition of science in order to accommodate multiverse as being science? Because they don't want just to admit that they're doing philosophy, because they don't like philosophy, and philosophy is no good, so they have to be doing science. But they're doing injury to science and to physics, because there's a reason why there's a scientific methodology that's been so successful, that demands observation, comparing your things to reality. And that's good. That's been really good and beneficial for science. And it's progressed so much over the past few hundred years because of the methodology of science. And to just change the definition of science to accommodate multiverse because physicists refuse to accept that they're doing philosophy, it's based on ignorance of philosophy. And it's really harmful to science. And exactly to your point, it's just, I think, a really big mistake that is very much the attitude to philosophy has really contributed to the rise of multiverse.
Yeah, so I love that you guys are offering a really well thought out treatment alternative to multiverse. And I was curious in your scientific mathematical landscape, if you see or sense any sort of more openness toward the argument for an intelligent cause, or is there any kind of openness, or it sounds like there's also some movement on the other side of things with redefining science and all that stuff, but where do you view the current conversation and where do you see it heading?
I think the problem is that there is a pervasive sense of knowing that God is impossible, that the idea of God as even just in the theism, or deism, even just as an intelligent cause of the universe, they know that's wrong, that's impossible, that doesn't make any sense, that's just a childish religious fantasy, and they know it's not true. And therefore, the only possible way to interpret this is a multiverse. And that's why they say multiverse, because they believe the idea of God is not true. And I think until that changes, I don't think they're going to be able to move off of multiverse. And that's why, look, we're coming in with season 2 of the Multiverse in November, but after that, probably about a year later, we're going to come out with our third part, and probably the final part, which is going to be about God. Because if you can't present to a rational scientist a clear, coherent, logical, cohesive, intuitive idea of God, and without answering these questions of who created God, or who designed the designer, or what does God even mean, they ask serious questions and that demand real answers. And if you can't, just like we presented the fine-tuning argument in a clear way, with analogies in a clear way, we're going to do that with the multiverse, with these analogies and the clear method. We're going to do the same thing for the idea of God, and showing how there is a clear idea of God that emerges from the fine-tuning argument naturally. And it's a satisfactory idea of one God who is the cause of the constants, and that is defensible, and that the same categories that physicists use to understand fundamental laws and fundamental constants and fundamental interactions between particles, things like that, we're using, in a certain sense, the categories of physics, fundamental physics, as an analogy for metaphysical categories, how you deal with fundamentals in a metaphysical framework. So it's obviously a little bit more abstract because you're using physics, which is hard enough as an analogy for metaphysics, but Ellie's going to give great analogies in that third part, and we're going to have to do that, because until you can present an idea of God that seems possible to scientists, they're just not going to be able to move off of the multiverse. But ultimately, I think multiverse is fated to fail. There's no way, in my opinion, I hope I'm right, is that there's no way that the heart of science and the spirit of science is going to tolerate multiverse forever. And it might take another decade or two, but it's just not real science. And there's just no way that it has any staying power in the long run. It's too big a corruption of what actual science is that eventually scientists are going to have to drop it. When that happens is obviously nobody can tell you.
Wow. I can't wait to hear all that, man. Sounds fascinating. Is there anything else you guys want to talk about? Or Nathan, are there any other questions? My mind's pretty full right now.
Yeah, I've got one more. It sounds like your podcast, you talk about intentionally focusing on the logic and the reason and the science without bringing in divine revelation. But it sounds like some of that might be coming as you begin to move into season 3, or maybe not divine revelation. But I'm curious why you guys chose to take that approach. And personally, also, I'd maybe love to end on a personal note, like how divine revelation, or maybe the lack of it, I don't know, has played a role in your own faith and academic journeys and all of that.
Right. Yeah, so I think is that when we discovered this argument maybe 10 years ago, and it got better and better as time goes on, we realized that, as Aaron was talking about before, we think there's a solid, convincing argument that God exists, that there's an intelligent cause of our universe from fine-tuning. And again, when you overreach, as Aaron quoted before, if you try to do too much, I think you end up not being able to be as successful. And we think we want to put our focus on what we think is solid, convincing, compelling. And if you could get people to see the idea that God exists, we think that's a major step. And while we do, of course, believe and have justification for other beliefs, which we have for divine revelation and all that, we think we want to focus on that which is a major issue in our day. I think atheism has took, especially new atheists, have took a lot of people and trying to convince people that modern science has showed that God is make-believe, that God is dead, that God doesn't exist. That's all this ancient thing. And we realize that this is an issue which every religion, whatever religion, any religious person struggles with this impression that atheistic scientists give that God is outdated. And we think that we don't want to, in a certain sense, we teach Torah and we study religion and we discuss those things in our classes that we give to in our communities. But at the same time, we think this has a very universal appeal. There's a compelling argument, which is solid and convincing for everybody, whatever your religion you're from. We think that there's a common battle, if you will, against atheists who maintain this world is purposeless, without any, just total random chaos, multiverse, everything is random. And we see that's a common problem, and we have a broad audience that we think we could share this idea with the larger world than focusing on the particulars which we teach about our religion. So while we think we have great ideas in that, and revelation we believe in, we think it's true and it's grounded, at the same time, we think this is a solid argument, which we're not really ready to go present anything like that, anything in this type of way.
Just add the idea that, well, in our podcast, we're really just trying to establish the foundation of religion and divine revelation, but we're not going to actually seek to prove that from physics and from science. In all likelihood, who knows what will end up happening. We do have arguments from, for example, for the Torah itself, and we live a life guided by the commandments and studying the oral Torah, the oral law that was in the Talmud. And as our life as Jews in terms of the land of Israel, and it's the return of the Jewish people. And then their life is very much influenced by our relationship to God in particular and divine providence. But like Ellie said, we thought it was very important that people should see that the idea of God is not contingent on divine providence. The idea of divine providence is contingent on the idea of God. You first have to know God exists in order to ask the question. Once you can know God exists, you can ask the question, does he relate to mankind or not? And I'll say one thing, it's a very different question. And the burden of proof is much lower when you're trying to prove divine providence after you already know that God exists. And very often people try to, again, in proper methodology, they try to prove everything. You try to prove that God exists. He probably prophesies gives prophecy to mankind. He does miracles. He relates to people in particular. And you're trying to prove those all at once. And that's a high standard. It's a high burden. But if you just break it up logically, what's the first thing that you have to prove? That's the idea that there exists a God. Once you know a God exists, that already gives a person confidence. Now, these atheistic scientists, you could see they're wrong. Don't just trust them. They believe that God never gave the Torah at Mount Sinai. They say that's not true. They also believe in a multiverse. And once you see yourself firsthand, that's the idea of the podcast. You're going to have firsthand knowledge that God exists and that the scientists are wrong about the multiverse. And you'll watch their videos about the multiverse, and you're going to see the smartest people in the world are believing in something that you can see yourself is wrong. That's going to give you a lot of confidence when you're facing these other issues and these other arguments of divine providence. It's like I said, the most important thing we think is to go logically and step by step. And once God exists, you'll be able to see afterwards, each on their own will be able to see it for themselves. And maybe we'll do something later on about that.
Yeah, that's great. Go ahead, Dan.
We talked in one of our early episodes about the case of Anthony Flew. And for those who don't know the name, in the world of philosophy, there are what you would call the popular atheists, the people like Richard Dawkins, who sell their books that are sold at Barnes and Nobles and whatnot, and they make the rounds of the talk shows, and they're on TV and whatnot. And then you have the more serious atheists, and probably the most serious opponent of theism in the last 50 to 60 years was Anthony Flew. He was a very intelligent British philosopher who wrote somewhere around 45 books about philosophy and about logic and reasoning especially. So his two specialties were analyzing reasoning and logic. So he wrote several great books on logic, and then also atheism. He was an atheist for almost all his life. And then in the last years of his life, he published a book called There Is a God, How the World's Most Notorious Atheist Changed His Mind. And if you look at that book, what he argues is basically many of the same things that you're arguing. What changed his mind was the evidence of the fine-tuning of the universe. And then he tried to reason what's the best explanation for that fine-tuning. And for him, as a logician, it became very clear. He said that he really did not want to go down that road, but he had made it his life's goal to follow the argument wherever the evidence led. And for him, the evidence led to the idea that it was much more rational to believe in the existence of a God than in naturalism. So anyway, I just thought you might find that interesting. Maybe you already knew that.
No, I really didn't know that. That is fascinating.
Yeah, me neither.
Thanks.
Yeah, and that book is on Amazon. It presents a lot of the same arguments, but it's on a lower level in terms of understanding. Anyone who can read college level material or high school level material can get that. And Anthony Flew, There Is a God, How the World's Most Notorious Atheist Changed His Mind.
Fascinating.
Yeah, I love your guys' approach and just how thorough it's been. I'm looking forward to season 2 and season 3 and appreciate how focused you guys have been, not trying to come up with answers for everything, but just to help people in that first step toward the possible existence of intelligent designers. So hats off to you guys. Well done.
Thank you.
Yeah, well, look, it's great to hear that people appreciate it. And it's amazing because I know you guys don't have, not physicists, but it was such a challenge for us to really break it down and make it accessible to everybody who's interested. And yes, you have to be intelligent to understand what we're saying, but you don't have to have a great scientific background. And it's great for us to hear you guys, your philosophy, not necessarily physics guys, but philosophy guys, and just to be able to hear you guys say that you appreciate it, you understand that it means a lot to us to know that these are the other people we're trying to reach, to hear these arguments and to make them available for people who are curious and genuinely interested in knowing whether there's a God from science, to make it accessible without having to go through years of schooling. So that it's good for us to hear you understanding the podcast and like you.
Definitely.
For sure. It was so nice to meet you guys.
Yeah,
Pleasure.
this was really interesting to me. Thank you.
Yeah.
Our pleasure. And maybe one time we'll do it again, but it was our pleasure to come on, and it was great to meet you guys. And thank you very much.
Definitely really enjoyed. Thanks.
Our pleasure.
Yeah, absolutely.
And again,
Yeah.
give my wholehearted recommendation if anyone's interested in this topic. There's a YouTube channel and there's also an audio podcast, correct?
Yep.
Both the same material, physics
Right.
wide.
Yeah, and you can go on our website, physicstogod.com, where we have essay forms of the podcast.
Oh, great.
Yeah, and you can subscribe. There's an email subscription. We don't send out that many emails. Maybe whenever we do, you'll get access to that. So those are the 3 different ways right now that the information is available.
All right. Anything else, guys?
No, I think
I think that's good. I want you to appreciate it. It was great to talk to you, and it was a great conversation. Really enjoyed it.
Thank you.
Great. Thanks so much.
Yeah.
Yeah.
Bye.
Thanks so much for listening. If you like what you hear, click follow or subscribe depending on your platform. Check the notification bell so you're up to date with new episodes and leave us a review. Until next time.